In this video, I will explain Activity 4 of Module F2, Graphs and Intersections. Now, this activity is pretty similar to the previous one, Activity 3, where we had to find points of intersection for two given formulas. Here we have to do the exact same thing, so again, we're looking for points of intersection for given formulas, but the only difference is that the formulas that they give us are mathematical formulas, and not practical ones. So you don't get a story about a taxi driver this time, but just regular mathematical formulas with x and y without the story about what these formulas are about. Now let's look at the example first. Here we are given two formulas, y equals 3x plus 8 and y equals 4x plus 2. You can leave out the multiplication dots if you like. And the graphs of these two formulas, they intersect each other here. And what we want is to find the coordinates of this point of intersection. Now here we can read it off because the graph is given, but it's more precise to calculate the point of intersection, and that's what they ask of us in this activity, so that's what we're going to do. The first step is to make an equation of these two formulas, and we do that by taking the parts after the equal sign for both formulas and writing them down with an equal sign in the middle. So we get 3x plus 8 equals 4x plus 2. So the next step would be to solve this equation, and we learned how to do that in Module V3 about the balance method. So if we solve this equation with the balance method, the solution will be x equals 6. And that's the x-coordinate of the point of intersection that we were looking for. We can check it by going down from the point of intersection towards the x-axis, and you see that we indeed arrive at x equals 6 on the x-axis. Now, the point of intersection consists of another number, the y-coordinate, and we can find that number by taking the solution of the equation that we just solved, 6, and filling it into either of the two formulas that they gave us to begin with. It doesn't matter into which formula you fill in the number, it will give the same result each time. I can show you. If you fill in 6 here, you get the calculation 3 times 6 plus 8, that's 26. If you fill in 6 here, you get the calculation 4 times 6 plus 2, that's also 26. So the y-coordinate of this point of intersection is 26. And we can check it again by reading it off towards the y-axis, where we indeed end up at 26. Now, let's look at exercise 1, where we have to do this ourselves. We are given these two formulas, and we need to find the point of intersection for these two lines. The first step is to make an equation of these two formulas. That's already been done for us here, but in the next exercises we have to do that ourselves. Now we have to solve this equation using the balance method, like we learned in Module V3. So we're going to remove all of the x's from the right-hand side, which means removing minus x by doing plus x. That means I get 4x on the left-hand side instead of 3x. Minus 8 equals 4 then. Oh, equals 4. There we go. Then we're going to remove the regular numbers from the left-hand side, and I can remove minus 8 by doing plus 8. That means I have 4x on the left-hand side, and on the right-hand side I have the result of 4 plus 8, which is 12. Now we have x's on the left, regular numbers on the right, so the last step is to find out what x is by dividing by the number in front of x. So we're dividing by 4, and the number that we're dividing by 4 is the number over here, 12. 12 divided by 4, that's 3. So x equals 3 is the solution to this equation. So that means that the x-coordinate of the point of intersection, which they ask for in question B, is the solution to this equation, 3. We can then find the other number for the point of intersection, the y-coordinate, by taking 3 and filling it into either of these two formulas. I showed you before that it doesn't matter which one. I'm going to go for this one because it's a slightly easier calculation. Filling in 3 for x gives the calculation minus 3 plus 4, and minus 3 plus 4 is 1. So that's the y-coordinate. Together, that means that the coordinates of the point of intersection is 3 for x and 1 for y, so 3 and 1 between brackets separated by a comma. Now, we can check that just this once in the pop-up screen. If we drag it to the side a bit so we can read what the formulas were, we can fill in the first formula here, 3x minus 8. And if you press enter, it plots it for you. Press the arrow down to get the second input of screen for the formula. Don't forget to tick the box, otherwise it won't plot it. And read what the formula was, minus x plus 4 minus x plus 4. And as you can see, it plots it. Now we can read off the point of intersection here. The x coordinate is 3, just like we calculated, and the y coordinate is 1. So this is in fact correct. Moving on to exercise 2. Here we have to do the exact same thing. So we are given two formulas of which we need to calculate the point of intersection. The first step is to make an equation, and again it's already been done for us, but you have to do it by taking the part of each formula after the equal sign and writing them down with an equal sign in between. Next, we are going to solve this equation using the balance method. Removing the x from the right hand side means doing plus x again, and minus 2x plus 1x is minus 1x, or just minus x, plus 6, and on the right hand side all we have left is 3. Now we're going to remove 6 from the left hand side, so we get minus 3 minus 6, that's minus 9. And if negative x is minus 9, then positive x has to be positive 9. We divide it by minus 1 here. So the solution to this equation is 9. That means that 9 is the x-coordinate of the point of intersection that we're looking for. The y-coordinate can be found by taking 9 and filling it into either of the two formulas that we were given in the beginning. So I'm going to go with this one again because it's easier. If I fill in 9 here, I get the calculation minus 9 minus 3. And minus 9 minus 3 is minus 12. As you can see, if I press enter here, it doesn't show the V symbol. Must be some kind of bug in the system. Minus 12 is the correct number. If we fill in the numbers 9 here and minus 12 here for the point of intersection, you see that it does count it as correct here. Now, we can use this screen again to check that we indeed did it correctly. Here I type the first formula, so minus 2x plus 6. And I wanted to go down to create the second input screen for the second formula, but the arrows seem to fall outside of the screen. So it's not possible to go any further than this here. Doesn't matter, we already have the answer. The point of intersection is 9 and minus 12. So in exercise 2, you cannot plot the graphs and check it that way. We're moving on to exercise 3. In exercise 3, we have to do the exact same thing again. The only difference is that now, the first step, we have to make the equation ourselves. Now, by now we know how to do it. We have to take the parts after the equal sign for both formulas and write them down with an equal sign in the middle. So I start with 4x minus 8, not 8, 4x minus 5, sorry, 4x minus 5, and I equalize it to a half x minus 12. So 1 over 2 x minus 12. This is the equation that I need to solve. It's done in the exact same way as the previous ones. So removing a half x from the left hand side means minus a half x. 4x minus a half x is 3.5 x. So that's what I should get here. 3.5 x and then minus 5. Well, not equals 5, but minus 5. And on the right hand side, all I have left is the minus 12. Now I remove minus 5 from the left hand side by doing plus 5. That means I only have the 3.5 x on the left hand side. Never mind. And on the right hand side I have the result of minus 12 plus 5, which is minus 7, I think. Yeah. And now in the last step we have to divide by 3.5. Minus 7 divided by 3.5, that's minus 2. So there we go. X equals minus 2 is the solution to this equation. That means the x-coordinate of the point of intersection of the graphs of these two lines is minus 2. The y-coordinate for the point of intersection can be found by filling in minus 2 into one of the two formulas. Let's just go with, I don't know, this one again. A half times minus 2, that's minus 1. And minus 1 minus 12 is minus 13, I believe. Let's check. Yeah, that's correct. So minus 2 and minus 13 are the coordinates of the point of intersection, which can be filled in here. And for some reason, don't ask me why, it doesn't count it as correct anymore. And it will continue to do that throughout the rest of the exercises. But no matter, as long as you have got the correct solution here and filled in that number and found the y coordinate of the point of intersection here, these two numbers together make up the point of intersection. It should count it as correct. I don't know why it doesn't do it. Here we can use the graph that's given to check that it's indeed correct. So let's do it. So 4x minus 5 is the first one. Now we can use the arrow again. Don't forget to tick the box. And the second one is a half x, 1 over 2. Oh, 1 over, why doesn't it work? That's strange. Let's click it just then, yeah. Minus, no, a half x and then minus 12. So the point of intersection is just visible right here. The x-coordinate can be read off like that, towards minus 2. Let's drag it a bit. And the y-coordinate is minus 13, so we were indeed correct. Let's move on to exercise 5. Something interesting happens from exercise 5 onwards. The graph isn't given anymore. They still say in exercise D, check the answer by filling in and taking the formulas, like we did in exercise 3, but the graph doesn't appear. So just ignore that last part, just solve the equation and fill in these two boxes, and that should be enough. Right, let's try this one. It has a fraction, so it's a little bit more difficult, but the way to go about it is the same. The first step is to make an equation from these two formulas, taking the part after the equal sign for both formulas and writing them down with an equal sign in the middle. So I get minus x minus 1 equals 1 over 3 x plus 7. That's the equation that I now need to solve with the balance method again. So I remove 1 over 3x from the left-hand side by doing minus 1 over 3. Here I already have minus 1x, and if I subtract 1 over 3x from that, I get minus 1 and 1 over 3x. So minus 1 and 1 over 3x on that side. Also, don't forget the minus 1. And on the right-hand side, all we have left is 7. Now we're going to remove minus 1 from the left-hand side by doing plus 1. So I get minus 1 and 1 over 3x equals 8, because 7 plus 1 is 8. In the last step, I have to divide by whatever I have in front of x. So I have to divide by minus 1 and 1 over 3. I have to divide 8 by that number. It will definitely be a negative result, because negative times something negative will give a positive number like 8. So x equals a negative number, and the result of 8 divided by minus 1 and 1 over 3 is actually minus 6. So minus 6 is the solution to this equation, which is also the x-coordinate of the point of intersection, minus 6. Now, to find the y-coordinate of the point of intersection, we will take minus 6 and fill it into one of the equations. The easiest one is this one by far. So minus x, so minus 6. Minus 6 is actually positive 6. And positive 6 minus 1 is 5. So 5 is the y-coordinate of the point of intersection. And again, if I copy these two numbers here, for some reason, It doesn't count them as correct, but they are indeed the correct numbers for the point of intersection. It will continue to count it as incorrect throughout the rest of this activity, so don't worry about it. The last one that I want to do is exercise 9, because there we have to remove brackets. Let's see if we remember how to do it. The first step is making the equation again. So I take 3x minus 3. You don't have to copy down the multiplication symbol. You can just stick the 3 to the opening bracket. On the other side, we get minus 2 bracket x minus 4 plus 13. This is the equation that I'm going to solve. And now the first step is to remove brackets. Here I can remove brackets by multiplying 3 by both things between the brackets. So first I do 3 times x, that's just 3x. And then I do 3 times minus 3, which is minus 9. So those are the brackets on the left-hand side removed. Next I go on to the other brackets on the right-hand side and I remove them in the same way. So minus 2 times x is minus 2x, and minus 2 times minus 4 is plus 8. Don't forget to copy down the plus 13 at the end. Now, the left-hand side cannot be written any shorter, but I can collect together the 8 and the 13 on the right-hand side. So first copy down the left-hand side again. Then minus 2x stays the same, but 8 plus 13 is 21. And now I can remove the x's from the right-hand side again. So I'm going to remove minus 2x by doing plus 2x, and 3x plus 2x is 5x. 5x minus 9 equals just a 21 on the right-hand side. And next we will remove the minus 9 by doing plus 9. So I get 5x equals 30, because 21 plus 9 is 30. In the last step we divide by 5. 30 divided by 5 is 6. So 6 is the solution to this equation, and it's also the x-coordinate of the point of intersection of these two lines. The y-coordinate can be found by filling in 6 for x into either of the two formulas. Let's go with the first one. We will get 3 times 6 minus 3. Brackets always go first, so calculate 6 minus 3 first. That's 3, and multiply that by 3. So 3 times 3 is 9. That's the y-coordinate of the point of intersection. So 6 and 9 are the numbers that make up the coordinates of the point of intersection, which again is counted as incorrect, but these are in fact the correct numbers. And I don't know why it keeps calculating it, why it keeps showing as incorrect.